Newton's first and second law. A force can cause an object to accelerate. If no net force acts on a body, the body's velocity cannot change. That is, the body cannot accelerate. In other words, if the body is at rest, it stays at rest. If it is moving, it continues to move with the same velocity, same magnitude, and the same direction. That is the Newton's first law. Then when we start this, we discussed about the force. Then what exactly force is? So we have a body here. We want to apply something, force power is one side. Then if we don't have this applied, originally the object was in rest, then it will stay rest. In order to make this as a moving or have change the status, original status, then we have to apply the force. So was original in the rest, they will stay rest. If this original in the moving status, then they will stay and continue as moving. They will not stop in order to change the status, in order to change the velocity. We have some sort of the force you apply to this object, this body. Then force is first, what is, and we know the power, we already know is what is a force. Then force has a unit. The force has a unit is Newton. So the symbol is N, Newton. The force unit, suppose we'll put a body which has the mass 1 kilogram on horizontal. So and we put this the body on the horizontal, and this is the condition has to be frictionless and surface, and we pull this body horizontal such that the body can have the acceleration of 1 meter per second square. Then we can define our applied force as having the magnitude of 1 Newton. The force is a vector. Okay, force is a vector. We know what I mean by vector. It has a magnitude and a direction. If we have more than one force applied to on a same body, we define that as a net force, or resultant of the force by adding them, or different force, adding those vectors together, that in the calculate what is net force. The single force has the same magnitude and the direction as calculated by force, would then the same effect as the individual force. Then in fact that's called the principle of the superposition of force. So we don't care about it as a multiple force applied to one body has the same the net force, or individual body in the force get the same result. That is for us as a result same. And as we know here, we also object, we have mass. We discussed about mass. Applying a given force to the body results in different acceleration. The body with the larger mass is accelerated less. So if we have the same force as we applied here, we have a smaller mass. This is a smaller mass. We have here is a bigger mass, larger mass. We'll apply same force. We apply this is a force magnitude like 1 Newton, and we apply same magnitude and same force. And here, second, this is a force 1, this is a force 2, but these two force has exactly same magnitude of force applied to same direction. Since this is a top one has a smaller mass, the bottom one has the larger mass. When we apply same force, the acceleration is different. So what is mass? So far, we really don't have the exact definition of the mass, but we know the mass is the intrinsic characteristic of the body. It automatically comes with the existence of the body, and it is a scalar quantity, doesn't have the direction. The mass of the body is a characteristic of that is related to a force on the body to the resulting acceleration. That was Newton's first law. Now we discuss about Newton's second law. The net force on a body is equal to the product of the body's mass and its acceleration. So in equation form, we can write force vector, that's a net, the force, that equals to mass multiplied by acceleration. This is Newton's second law. So when we apply this as a Newton's second law solving problem, we always need to identify the body. So first we need to identify we must be certain about which body we are applying it to. And then must be the vector sum of all the force that act under the body. Because the force, they all this different force applied to the body, that net force is the sum of this multiple force, that's vector sum will result the acceleration. That's why we need to identify the body, what the body is on we are talking about. And the second, we need to apply separate the axis. It is equivalent to 3 composition equations, one of each axis for XYZ coordinate system. More precise speaking, the net force of X component should be equal to mass of the body axis X component. And the net force on Y component will be equal to mass times, what I did here, it should be x-axis. And this is the acceleration Y component. And the third, net force on the Z component equal to mass times acceleration, the z component. And the force in equilibrium. If the net force on a body is 0, the body's acceleration is 0. Okay, so this is in third. It's a force in equilibrium. And the next we want to see there's a force as our units. Unit is a 1 Newton. 1 Newton is equivalent 1 kilogram of the body obtain 1 meter per second square of the acceleration. That's equivalent to 1 kilogram multiplied by meters per second square. That's equivalent to our 1 Newton as a force unit. And the next one is we only discussed about external force only. The reason is the system consists of one or more bodies, and any force on the bodies inside the system from the bodies outside of the bodies is called external force. If the bodies making up the system are rigidly connected into one another, we can treat the system as one composite body. The net force on it is a vector sum of all external forces. We do not include internal forces that within it. The force between two bodies inside the system, internal bodies cannot accelerate the system. And whenever accelerate the body, only was a result of the external body. If more than one force is applied to same body, then it will be net force of that result. That is the Newton's law, first law and the second law. I will make another video for come up with some practicing related to that we can solve applied to our Newton's first law and the second law. Keep watching. Thank you for your subscribing my video. Thank you.